In this lesson, we'll be looking at how we can take advantage of hexagonal architecture in our NestJS applications. So, let's start off by heading over to our IDE and take a look at the code we have at the moment. Inside of our alarms directory, we can see that we have a controller, a service, and a module class. As we know, the controller is responsible for handling incoming requests and returning responses back to the client. The services in our code base contain the business logic of our application, and the modules represent the bounded context, defining the dependencies and the components that belong to each module. So nothing new here so far, right? Alright, so let's kick things off by creating 4 new folders inside of the alarms directory, named Application, Domain, Infrastructure, and Presenters. And let's stop here for a second to explain each of these folders and what they represent. The application folder here will contain the application services, facades, handlers, and other application-specific components, which all represent the application layer. It will communicate with the data access components, message brokers, and other external systems through interfaces called ports. The domain folder will contain the domain models, value objects, domain events, and other domain-specific components, which all represent the domain layer. The infrastructure folder will contain the data access components, message brokers, and other external systems which represent the infrastructure layer. It will implement the interfaces, aka ports, defined by the application layer. And lastly, the presenters folder will contain the controllers, gateways, and other user-facing components or APIs. Sometimes the presenters folder is also called the user interface folder, sometimes just interface, but we'll stick with presenters since it seems to be a bit more self-explanatory. Note that this is just one way of structuring your application. You could also structure it differently depending on your needs and preferences. It generally boils down to how granular you want everything to be within your layers. Okay, so back to our task at hand. Let's move the alarms service and alarms module files to the application folder. Next up, let's create a new directory called HTTP inside of the presenters folder, and let's move the alarms controller as well as the DTO folder inside of it. This HTTP directory will now represent the HTTP layer of our bounded context called alarms. All of the import statements should automatically be updated by our IDE, but if they're not, make sure to update them manually. Also, before we proceed, let's remove the entities folder as we'll be creating a new one soon. Now, inside of the domain folder, we'll create a new file called alarm.ts with the following content. This class will represent our domain model. We'll be adding more logic here in the future, but for now, let's keep it simple. So as we can see, the alarm severity doesn't exist yet. So let's go ahead and create a new file called alarmseverity.ts inside of the domain/value-objects folder with the following content. Great. But what does value object mean here in the first place? Well, a value object definition originates from domain-driven design, or DDD. A value object is an immutable object that represents a descriptive aspect of the domain with no conceptual identity. Two value objects are equal when they have the same value, not necessarily being the same object. Value objects should be immutable and side effect free. Now with this in place, we can add the missing import statement to the alarm.ts file. Also, inside of the factories directory, let's create an alarm factory file with the following content. Perfect. Now with this in place, let's navigate to the alarms controller and remove all methods except for create and find all, just to keep things simple, as we'll only be using these two methods in the following lessons. Similarly, let's navigate to the alarms service and remove all the unused methods there as well. Let's stop here for a moment to discuss a few things. So since our data transfer objects, DTOs, are now located inside the presenters folder and belong to the presentation layer, we can't really reference them in, let's say, the application layer. We could, in theory, move them here to the application folder. However, they contain validation decorators and they represent the shape of the data that is sent over the network. which is a shape specific to the HTTP API. So, as purists, we should keep them in the presenters folder. Otherwise, other transport layers, for example gRPC, would have to reference them as well, which would be even more confusing. So, what can we do here? Well, we can either use the any type for the time being, or create yet another class called, for example, payload or command and use that here instead. Since in this course, we're going to eventually introduce command and query classes later, let's go ahead and create a new directory called commands inside of the application layer. And inside of this folder, let's create a new file called createAlarmCommand with the following content. Let's save our changes and use this type instead of the createAlarmDTO in the alarm service. Next, let's make sure to update the alarms controller to construct the createAlarmCommand object and pass it to the create method instead of the createAlarmDTO. Also, let's update the createAlarmDTO to contain two properties required to create an alarm: name and severity, both which are strings. And last but not least, let's open up the alarms module and register the new alarm factory as a provider, since we'll be using it in future lessons. Let's save our changes, and if we head over to the terminal and run the application, we should see that everything's working as expected. So far, so good. As we can see, our application is now structured differently than before, which was the traditional setup we see in NestJS applications. We're slowly heading towards the hexagonal architecture, but we're not quite there yet. We still need to define the interfaces or ports and implement them via adapters. Don't worry if this all doesn't make much sense yet. It'll become clearer and clearer in the following lessons as we build everything out piece by piece.